In this video, we'll continue our discussion of finding extrema using the Hessian. So we're given a function here. We don't have any bounds or anything like that. We're just going to find any relative extrema if we can. Right, so we have our function. The first thing we're going to do is find our partials. So the partial of f with respect to x is 2x plus 2xy. Okay, and then we take our partial with respect to y, and we got 10y plus x squared plus 6y squared. All right, let me double check that real quick. I think we're okay. I think we're all good. All right, we got that. Okay, now we create a system. 2x plus 2xy equals 0. And then we also have 10y plus x squared plus 6y squared equals 0. All right, we got to do anything we can. I see the quadratics with the x squared. So not a big fan of those. So let's see what we can do. I see the 2x's up top, and I'm kind of curious to see where that could take us. So let's divide out a 2x there, or factor out rather, and we get 2x times 1 plus y equals 0. I could take that route that we did last time. I think that may be our best bet. In the last video, in the tricky systems, okay, we can let x equal 0. We'll use the zero product property there. We'll do two paths, x equals 0, and then we'll do y plus 1 plus y equals 0 as well. Okay, x equals 0, I just use that in the other equation. I get 10y plus 6y squared equals 0. I can factor out a 2y, leaving me with 5 plus 3y. That's equal to 0, so I get two values here. I get y equals 0, and then I get 5 plus 3y equals 0, so that means y is negative 5/3. So I'm going to make a list of critical points we're going to use. So I'll do it right here. Critical points. The first one is going to be 0, 0. The next point is going to be 0, negative 5/3. Right? This gets me y equals negative 1, so that's what I'm going to plug into the other function. So I got 10 times negative 1 plus plus x squared plus 6 times negative 1 squared equals 0. That gets me negative 10 plus x squared plus 6 equals 0. And then I got x squared equals 4, which tells me x is plus or minus 2. So that gets me 2 more points. I got 2, negative 1, and 2, negative 2, negative 1. Right, I'm going to use those points now to run through the Hessian. The Hessian is capital dxy is equal to the double partial with respect to x times the double partial with respect to y minus the mixed partial squared. All right, so I need to find those things. So we have our f here at the top. We have fx already. I'm going to go ahead and put that right here. Fx is equal to 2x plus 2xy. Fy is equal to 10y plus x squared plus 6y squared. Okay, we have to find fxx. Okay, that is going to be 2 plus 2y. We also need to find fyy. That is going to be 10 plus 12y. And then we also need fxy, and that's going to give me a 2x. All right, the Hessian in general, we're going to need it here because I've got to plug it in through 4 different points, is going to be 2 plus 2y times 10 plus 12y minus 2x squared. All right, so let's plug all these in. Okay, the 0, 0, if I plug all that in, I am going to get 20, which is greater than 0. So I need to go ahead and plug that into xx, 0, 0. If I plug 0, 0 into xx, I get 2, which is greater than 0. That's a positive concave. So this is a relative min at 0, 0. All right, so there's one of them. Okay, we have that. We also got to run the Hessian with 0, negative 5/3. Okay, it's not going to be as fun to plug in here. We really only care about sign, so, well, we're still going to have to do it. 2 plus negative 10 over 3 times 10 plus negative 60 over 3 minus, and then plugging in 0 squared. Okay, that's going to be, okay, we have a negative and that's going to be 20, a negative, so that's going to make a positive, so it's greater than 0. And then we plug this into xx, and we don't, if we plug negative 5/3 into that, I get negative 10/3 plus 2, that's going to be a negative. So as concave going that way, this is a relative max at 0, negative 5 over 3. Okay, I got to shrink that up because I'm going to be out of room. Oh, let's skip to the next page. Sorry about that. All right, so there we go. There's the next one. And then I'm going to shrink this down so I can have more room. Cool. Right, now we got to do the same thing, but for the point 2, negative 1. So we have 2 plus 4 times, or it's plugging in negative 1. So that's going to be plugging in negative 1 there. I got a 0. And then I got 10 minus 12 minus 4 squared. So we're going to get a negative 2 minus 16, which is less than 0. So it's it's a saddle point. So saddle at 2, negative 1. All right, so we have a saddle there. And then we're going to do the last one, the Hessian at the point negative 2, negative 1. But the same thing, I get 0 there. Ooh, and I made a mistake. Let's go back. Some of you guys are like, yeah, I was trying to point that out across the screen. Doesn't change anything, so let's actually do this. We got a saddle still, but this is going to be a 0. I'm glad I caught it here, and some of you guys can't hate me for that. Video mistakes, I'm sorry, it's going to happen. I have nobody here to correct them for me, so please be graceful. All right, so there we go. We got a saddle at that point. There's my other one. Leave that like that. Okay, and then I got 0 with that negative 1. Then I'm plugging in negative 1 again. I got negative 2 minus, okay, and then this is going to be a 4, negative 4 squared. So we actually end up with negative 16, which is the same thing. A saddle at, since it's less than 0, saddle at negative 2, negative 1. So definitely an interesting function. All right, we have several things going on. We have a max, a relative min. And then we also have 2 saddle points in our function. We are not going to, like in Calc 1, I think you guys found max min, and then you'd have to sketch based on that. You can probably guess how horrific that would be in 3 space, so we will not be doing that. So we are just finding extrema and leaving it be.